Hi everyone, in this video we're going to be talking about quadrilateral coordinate proofs. So a coordinate proof is basically one that uses formulas and calculations to prove geometry concepts. It is different than statement reason proofs with the two columns that you might have seen before. And the formulas that are usually used with quadrilateral coordinate proofs are distance, slope, and midpoint. So for the sake of keeping this video brief, I have gone ahead and filled in a lot of the notes here. So if at any point throughout the video you need more time to copy something, absolutely just pause the video. So let's just review the three coordinate geometry formulas that we could use for these proofs. The first is distance. Now the distance formula is really just a reworking of Pythagorean theorem. So I will talk about the Pythagorean theorem option when we look at one of the problems. But the distance formula is that big radical x2 minus x1 squared plus y2 minus y1 squared. And distance can show that segments are congruent. Slope formula is y2 minus y1 over x2 minus x1. We could also fill in here that that's rise over run. If you prefer to use a graph and count boxes to find your slope, that's completely fine. And slope can show that segments are parallel or perpendicular to one another. You might remember that parallel lines have the same slope, whereas perpendicular lines have slopes that are negative reciprocals of one another. Midpoint formula, this one's probably used the least frequently here. It's x1 plus x2 over 2 and y1 plus y2 over 2. Basically the average of the x values, average of the y values. And that can be used to show that segments bisect each other. So what we're going to do is we're going to look at a table that kind of goes through the 6 main quadrilaterals and how you would prove them. So again, just for keeping the video shorter than longer, I have filled a lot of this in here and we're going to kind of fill in the blanks together. So I'll do this in a different color so you can see what I'm adding in here. So one thing I want to mention before we go through these methods is that I'm going to go through one key method for each of these 6 quadrilaterals. There are other methods that exist because a lot of these shapes have many properties that can be proven with coordinate geometry formulas. So I'm just going to be going through my suggested method for each of the 6 shapes. So for a trapezoid, if we think about the properties of a trapezoid, it's that at least one pair of opposite sides are parallel. So I'm going to fill this word parallel in here. And now let's think, okay, how can I show that things are parallel? Go and refer to your chart above. We can show things are parallel by using the slope formula. So I'm going to say that we're going to use the slope formula and we're going to do it 2 times. We're going to have 2 sides that are parallel to one another, so slope 2 times to show at least one pair of opposite sides are parallel. All right, if it's an isosceles trapezoid, you still have to do the stuff for a regular trapezoid. But in addition, you're going to show the other pair of opposite sides are congruent. That's what makes it isosceles. And how do we show things are congruent? Look above in our chart. That's by using the distance formula. So since we're going to be showing 2 sides are congruent, we are going to use distance 2 times. All right, for a parallelogram, this is one where there's definitely a bunch of methods that you could use. You could use midpoint to show the diagonals bisect each other. You could use slope to show that opposite sides are parallel. The way that I personally prefer to do it is by using the distance formula 4 times to show that opposite sides are congruent to one another. I personally prefer distance formula over slope, so that's going to be the method that I showcase within this video. For a rectangle, we are going to use the distance formula 6 times. We want to show the opposite sides are congruent, but that won't be enough to make it a rectangle. That will make it a parallelogram as we just talked about. So now we also have to show the diagonals are congruent. For a rhombus, think about a main property of a rhombus. All of the sides are equal. So we are going to use the distance formula 4 times, 1 on each of the sides, to show all 4 sides are congruent. And finally, for a square, we're going to use distance 6 times to show that all 4 sides are congruent and also that the diagonals are congruent. So if you know that the shape has congruent diagonals, that's when you would do this extra component of finding the distance or the length of those two pieces. All right, so we're about to look at a bunch of coordinate proofs. Again, for the sake of the video, I have already completed them. I'm just going to walk you through them. All right, we're gonna do one per shape. So number one, prove that ABCD, here are the coordinates, is a trapezoid. First thing I did was I plotted the picture. Now, sometimes it might say that plotting the picture using the graph paper is optional. I personally prefer to graph, and here's why. If I think about a trapezoid, I know that at least one pair of opposite sides are parallel. If I graph it, I can see that it looks like AB and DC are those parallel sides. And now that tells me what two sides I should find the slope of. So I found the slope of both of them was 2/3. We're gonna reduce our slopes. And then we write a conclusion at the end, basically explaining what we showed. So ABCD is a trapezoid since at least one pair of opposite sides are parallel since they have the same slope. Okay, and that would be a completed proof on how to prove a quadrilateral is a trapezoid. Let's take a look at one that would be an isosceles trapezoid. So again, I have gone ahead and graphed the picture. I can see that it looks like segment PQ and RS should be the parallel sides, and that QR and PS are going to be the congruent sides. One thing to note on these problems is that they are not questions. It is not saying, is it an isosceles trapezoid? So it's just stating the fact that it is. We just have to prove it mathematically. So your number should work out. Your graph should work out. Like this should appear to be an isosceles trapezoid when you plot the points and connect them. So I found the slope of the two sides that I thought looked parallel. They did have matching or equal slopes of 1. Great. Then for the other two sides, I could have used distance formula, but I noticed that these segments were just horizontal and vertical. So I took the quicker route of just counting those boxes on the graph paper. And I made a note of that here. They were equal, they were both 3. So our sentence at the end, PQRS is an isosceles trapezoid because at least one pair of opposite sides are parallel because of the same slope, and the other two sides are congruent. Your conclusion should be just like when you write a conclusion in an essay and you tie everything together. We're tying everything together here. We're talking about, well, what were we trying to prove, what shape it was, what letters, PQRS in this case, what formulas did we use, and why. All right, number 3 is going to be a parallelogram. Parallelogram, we said before that our suggested or my suggested method is using the distance formula 4 times, and that means for each of the 4 sides. When you are finding this, you can see in the picture that it looks like AB and CD are opposite one another, or they are opposite one another, and therefore they would be congruent if this is a parallelogram. So I can tell that this is working because I see radical 10 and radical 10, that those answers match. I see that the other two sides that appear to be parallel are in fact congruent, and they both were radical 13. So my conclusion is ABCD is a parallelogram because opposite sides are congruent. The reason I like the distance formula is I think this conclusion gets the point across a little bit quicker rather than talking about parallel, perpendicular, and how you know that based on slope. All right, number 4. Prove it's a rectangle. You can see a little lengthier here because I have now done distance formula 6 times. So I did the 4 sides. Notice radical 90, radical 90, radical 10, and radical 10. That shows me opposite sides are congruent. The 2 diagonals have the same measure. That shows me those are congruent. So I concluded ABCD is a rectangle because opposite sides are congruent and the diagonals are congruent. Number 5 is a rhombus. In a rhombus, all 4 sides have the same length. So notice how all 4 answers came out to be radical 58. Now let's say you got 3 answers to be radical 58 and the 4th side came out to be anything else. Let's say radical 56. you know to go back and check your work. Again, reminder, these are not questions. It is a rhombus. We just have to prove it. So we need to make sure our calculations show whatever the problem is trying to get us to show. My conclusion, pretty short. MATH is a rhombus because all four sides are congruent. Number 6, proving it's a square. Back to distance formula 6 times. You can see all four sides here are equal and the two diagonals are equal. If you wanted for the diagonals here, you could have just done or could have avoided the distance formula by just counting the boxes since they're horizontal and vertical. And then I wrote quadrilateral MATH is a square since all four sides are congruent and the diagonals are congruent. So those are the 6 quadrilaterals and what it would look like in a sample coordinate proof. I do want to show you one more proof in this video. So this one just has an extra part to it. So it says prove that A, B, C, D are the vertices of a parallelogram. Well, that's not really new, right? We did that in one of the previous questions. We plot the points. We do distance formula 4 times. We see that the opposite sides come out to be the same value, and we write our conclusion. ABCD is a parallelogram because opposite sides are congruent. There's nothing new there. However, this problem has a part B to it, and it says prove ABCD is not a rhombus. When there's an extra part, sometimes you might need to do an additional calculation, but I already know in this problem that it's not a rhombus because I have found the length of all four sides and they're not all the same. So all I'm doing is just writing an extra sentence here and saying ABCD is not a rhombus because all sides are not congruent. Okay? So again, just wanted to show you this one last example. If it ever says not, like this one here, you might have to do more calculations or you might not, depends on the problem. But definitely you need to write an additional sentence proving whatever it was asking for. Hopefully this video helped you get a good overview of how to complete coordinate proofs for quadrilaterals.